Okay, outliers and extreme values. This is a very, very important topic. So the most important almost from what we have learned so far. Just remember that we are still doing our analysis, our quality analysis on one variable. So it is a variable wise assessment. So what are outliers and extremes? Well, the terminology is not a universal terminology. So I'm using the terminology for the scope of this module, but the concepts, the things that you have to be focused on is universal. So outliers in general are the values that are far from the crowd. And by the crowd, I mean the crowd of values. Okay, so there is a one variable, and most of the values of this variable, so it is composed of values. Most of them probably are similar and close to each other, but there are some that are extremely different, very different. Okay? So in order to detect outliers, in order to measure the degree of being outlier, we need to think about a way to measure that crowd, okay, and the distance from that crowd. So we need to find a way to define a crowd and distance from the crowd. And if the distance is very far, it means that this value is lying out or lying somewhere far from others. It is abnormal. So an example is in a species with a weight of 5 to 7 kilogram for adults, an adult animal with 10 kilogram weight, or one with 2 kilogram weight. In this example, if this is the distribution of weight of those animals between 5 and 7, let's say, so better to move this one here, better 5 to 7. So this is the distribution of the weight of those animals. Then we found one animal, an adult, a healthy adult, or maybe unhealthy adult, doesn't matter, here, 2 kilogram, or someone here, 10 kilogram. So it's a deviation from the norm. This is the norm, and this is deviation. Imagine that you are a vet, and one of the things that vets do is weighing the pets, okay? And they have a norm in their mind for an adult pet, for a baby pet, a puppy, let's say, or a kitten. And then based on that norm, the vet can say whether the weight of a specific case is far from the norm and whether it's outlier or even more severe. Okay? So this is a measure, a quality measure relating to numerical variables. Okay? So for categorical variables, we do not have anything such as outlier and extremes. So what is the difference between an outlier and extreme? Well, it's a separation. It's an arbitrary separation. So basically, one is more severe than the other. Okay, so extremes, let's say that they are more severe than outliers. It's nothing important for the conceptual part of this module. The important part is to understand that the definition of outliers and how in general we measure them, and also when to do so, when we have a numerical variable. But why do they matter? So this is the when part. Why do they matter? They might be due to an error in data collection, so a stage 1 quality issue. Or they might be the reality of the phenomenon that adversely affect our modeling, a stage 2 issue. For instance, if you have someone with 240 centimeter height in your high school in the data set, you might think that this is something, that this is an error. This is due to a recording error. But if actually you have someone so tall, then the stage 1 quality is passed, and we have to think about stage 2. Okay, we do not want to remove this from the data set. We will see it in a minute, but we need to think about it, because such an outlier, such an extreme value, such a value that is far from others. Normally, we are somewhere between 150 to 180, right? Or let's say 190. And when someone is very far from this range, then this value might affect the modeling. Our model might not be able to learn from this and might want to discard it, disregard it basically, not discarding it. So disregarding the value. And we don't want it to happen. We want to help our model to learn from this value as well. It might happen that there are some regression methods or classification methods, especially multiple linear models, that they are sensitive to such values. They are not robust. So they are not robust. And these extreme values, these outliers, affect them adversely. They mess things up. So we need to think about them. After we are sure, we are certain that this is actually a reflection of the reality, we need to think that what to do with them. But before thinking about what to do with them, we have to define some ways, some tools in order to detect such values. Well, as I said, that we need to somehow define a crowd and somehow measure the distance from that crowd. As our variable is numeric, we are tempted to summarize our variable into its central point. Either it is mean or it is median. So it is not a vague term anymore as crowd. It is a very clear term such as mean or a median. And if we calculate the mean, then if we calculate the distance from this mean, we can set up a threshold in order to say that if distance from this mean is greater than a threshold, then this is an outlier. Or if this distance is from the median is greater than this threshold, then we have an outlier. So a little bit of arbitrariness is here, but still way better than talking about crowds. So these two things, the first one, the IQR one and box plot one, is about the median, and the standard deviation one is about the mean. Let's go through them. Let's go through them. So a box plot is a box starting from the first quartile. And let's say this is the second quartile, which is the median. And this is the third quartile, which is 75% into this or sorted data. What we do is calculation of this distance. We call it interquartile range. And then there is one arbitrary factor, 1.5 multiplied to IQR. If you calculate it, you find a range. Okay, this is the range. And anything below this range or from this side beyond this range, general above that range, would be considered either as an outlier or extreme value. Okay, so even though I said that from the median, actually it is from the first quartile, so the first quartile and third quartile, but the concept is the same. So I rather to keep it around the median thing, because then it resonates with around the mean. Okay, so this is the idea. Basically, with a first and third quartile, we define a crowd, and then we calculate this 1.5 multiply IQR and what we have here, and what we have here. Anything beyond that range would be considered as too far from the crowd. So any value in those regions actually would need further attention. But what about standard deviation? So if you recall, standard deviation is calculated like this. We calculate the mean of the variable, and then for each value in the variable, we calculate this distance. But this distance sometimes is a positive, sometimes a negative. So it's better to square it and better to sum it. Okay, aggregate all these values. The thing is, so we don't want we want to get the average of the distance from the mean, and by the average, then we need to divide it by n or n minus 1. It depends whether we have a sample or population beyond the scope of what you are learning. And then we use a square root to bring it back to the unit of the value of the variable. Okay, so the concept is like this, that the distance from the mean on average, this is called a standard deviation. So standard deviation is something that we calculated for a numerical variable. And it is the average distance, so average distance of the values from the mean. Okay, and now we can do something else. Now for a specific value, let's say xi, okay, or let's say for a specific value x3, let's say, okay, a specific value, we can calculate this distance from the mean divided by a standard deviation. Basically, we want to see that how many how many standard deviation a value is far from the mean. Okay, so if we just calculate the denominator, it might be 100, it might be 50, it might be 0.38. Doesn't make sense that much. We need to somehow make it standard, and this is why we use standard deviation. Okay, and we can see that then if this distance is basically right, like 2 times or 3 times than the standard deviation, then we can say that whether our value is an outlier or it is an extreme, so too much outlier. Okay, so coming back to review the previous slide, let's come back. We talked about how to detect outliers. So in order to detect them, we need to define a crowd, and we need to define a measure of distance from the crowd. And there are 2 simple ways at this level of learning. One of them is based on box plots and IQR, interquartile range. The other one is based on standard deviations. How many standard deviations a value is far from the mean. So knowing everyone, so knowing, or better to say, detecting the outliers or extreme values, now we have to decide what to do with them. Okay, this is not the goal, this is a means for the goal. What to do with them, how to treat them. Well, one way is just removing them from data. This is a very, very bad practice. So always keep in mind that removal of values is allowed when they do not represent the construct, or better to say, the phenomenon. Okay, so if these values are actually a reflection of the reality, then why should we remove them so blindlessly, so mindlessly actually? So removal is the last resort. Okay, you have to keep in mind. So what to do with them? Once again, one technique is transformation. If you recall, few slides before, we talked about some transformation like logarithm transformation, that they can reduce the skewness. And therefore, if we have a variable with 1000 values and 35 outliers, using a logarithmic transformation, we can convert it to a variable of 1000 values and 5 outliers, let's say. So we can alleviate the problem. But what if you figure out that these values are not reflecting the reality that we want to study? In that case, you can remove them from, so you are allowed to remove them from the data set. And then instead of outliers, we would have missing values. So no more outliers in that case, we would have missing values on that case. And how to deal with missing values, this is the topic of what we are going to learn.